Okay, so we're now going to learn how to use matrices to solve systems of equations. Systems of equations was introduced in Algebra 1, and then we reviewed that in the first part of our chapter here. So I started off the day with another a basic systems question. And they ask us, the machine counted your nickels and dimes. How many of each coin did you have? Explain. So they give us two things here. The coins counted were 184 coins, and the cash value of those coins was $14.35. So you can make an equation off each one of those. So off the coins counted, we can say there's 184 coins made up of the number of nickels plus the number of dimes. So we'll let N represent the number of nickels and D represent the number of dimes. So the next thing they give us is the cash value is $14.35. And we know that that's made up of the number of nickels times 5 cents plus the number of dimes times 10 cents. Okay? So is everybody with me to there? Now how would you solve for this? Well, you would take the most simple equation, this first one, and you would solve for either N or D, and then substitute that into the next equation. So letting N represent the nickels, D represent the dimes, there's our two equations, the coins, N plus D equals 184, and 5 cents times the number of nickels plus a dime, or 10 cents times the number of dimes is equal to $14.35. So you're going to solve for N or D. So I solve for D. The dime is equal to 184 minus N. That means that in the next equation where we see D, we're going to replace it with 184 minus N. So there it goes in our dime position. And then you just solve for N, right? So you take it all the way down till you get the number of nickels is equal to 81. So if we have 81 nickels, that means that the rest of those coins were dimes. So do 184 minus 81, and you get the number of dimes was 103. So you find out that you put 81 nickels and 103 dimes in the change machine. And that's how we used to solve systems. Today we're going to talk about how you can use matrices to solve systems of equations. When we solve a system of equations, we have to learn about matrix multiplication a little further. So if I have matrix A times X equals B, well, you would say, well, if we want to solve for this matrix X, the unknown matrix, well, why don't we just divide both sides by A? Well, we never talked about doing division with matrices, and nor will we. What we have to do, sort of like clearing a fraction. Remember when we have like 2/3 X equal something 5? What did we do to clear that fraction? Multiply by 3/2. Right? And it knocks it out. Well, we're going to do the same thing with matrices, except we're going to use the inverse. Remember, when you multiply a matrix by its inverse, you get that identity matrix, which is basically just 1. So what we're going to do is to solve these, we're going to first multiply by the inverse. If I could write. Okay, so these cancel out to the identity matrix, which I just don't even write. So it's basically X is equal to the inverse of A times B. And these all represent matrices. Okay? And this is the concept of what we're going to do today. This is on the test. I'm going to start off with the review of yesterday, and I'm going to show it with this video.
Hello, my name is Mr. Scott, and I will be helping you with solving 2x2 matrix equations. We'll be using this property that says if the inverse of matrix A exists, you can use it to solve matrix equations of the form A times X equals B. If you have a matrix equation in that form, then X is equal to the inverse of A times B. Now let's talk about how to find the inverse of a matrix. For matrix A, which is a 2x2 matrix with the elements A, B, C, and D, if the determinant of A is not equal to 0, then the inverse of A equals 1 divided by the determinant of A times the 2x2 matrix with the elements D, the opposite of B, the opposite of C, and A. To find the value of the determinant of A, you can use the expression A times D minus B times C. A special note about finding the inverse of a matrix is if the determinant of A equals 0, then the inverse of A does not exist. So watch out for that situation. Now let's use these two concepts to work through an example problem together. We want to solve this 2x2 matrix equation that's in the form A times X equals B. So our first step is to find the inverse of matrix A. Recall that this is the formula you can use, and we need to find the value of the determinant of A. So what do you think it is? Is it 0, negative 2, negative 22, or 2? Choose A, B, C, or D.
So I want you to solve. What is the determinant of that matrix? Remember, you're just going to multiply the diagonals and solve. By taking the difference. So we're going to go, the determinant is negative 2 times 5 minus 3 times negative 4. So what would it be? What's negative 2 times 5? Negative 10. So we're going to subtract from that negative 4 times 3. What's that? Negative 12. So negative 10 minus negative 12 yields what? Positive 2. So number D is correct.
That's right.
Letter D.
All right, you chose correctly with choice D. 2 is the value of the determinant of A. And hopefully this is the way you found it. In matrix A, the value of element A is negative 2, element D is 5, B is 3, and C is negative 4. And when we simplify that expression, we get 2 for the determinant of A. Now inside the 2x2 matrix, we want to write for D 5, the opposite of B is negative 3, the opposite of C is 4, and A is negative 2. So the inverse of A is 1/2 times the 2x2 matrix, 5, negative 3, 4, and negative 2. This is what we want to use to solve our matrix equation. Remember that from our first point of this tutorial, X equals the inverse of A times B. So we can say that X equals 1/2 times the 2x2 matrix 5, negative 3, 4, negative 2 times the matrix 6, 8. Now for our next step, let's multiply the 2x2 matrix by the 2x1 matrix. So we need to multiply the elements in row 1 of the 2x2 matrix times the elements in the column of the 2x1 matrix. So we need to multiply 5 times 6 and add negative 3 times 8. That'll give us the element in the first row, first column of our product matrix. For the element in row 2, column 1, we need to multiply the elements in row 2 of the 2 by 2 matrix times the elements in the column of the 2 by 1 matrix. So we need to multiply 4 times 6 and add negative 2 times 8. Okay, x equals 1/2 times 5 times 6 is 30, and negative 3 times 8 is negative 24. 30 plus negative 24 is 6. Four times 6 is 24, and negative 2 times 8 is negative 16. 24 plus negative 16 is 8. So x equals 1/2 of the matrix with the elements 6 and 8. 1/2 times 6 is 3. And 1/2 times 8 is 4. So x equals the 2 by 1 matrix with the elements 3 and 4. And that wraps up our example. Great job. Now remember the steps. Step 1 is to find the inverse of A, and you use the formula 1 divided by the determinant of A times the 2 by 2 matrix D, the opposite of B, C, the opposite of C, and A. And step 2 is if your matrix is in the form A times X equals B, then X equals the inverse of A times B. And use that to solve your matrix equations. Well, I hope you found this explanation to be helpful. And when solving 2 by 2 matrix equations, work well.
Okay, so I will also add a link on your Google Classroom to this video. So, because I know the sound doesn't always come out very well when I do these recordings. Okay, so let's just go straight to our homework. And remember, if your determinant is 0, there is no inverse. Right? So it wouldn't be possible. All right. So let's look at the first problem. Now, this is on your test. Okay, and this will be the last problem on your test. But we're still going to do the next problem set in the homework. Okay. So it says solve each matrix equation. To start, find the determinant of the coefficient matrix. So I'm going to go ahead and just do this. Right, now when we look at this, you've got, here's matrix A, X equal matrix B, right? So to solve this, we know that we're going to multiply each side by the inverse, and then this goes to the identity matrix, and we have that X is equal to, I do that every time, the inverse of A times B. Right, that's what we're working for. Okay, but let's look at how they take us through here and give us the steps. So it starts off with our equation. Next, we have to get the determinant of this matrix, right? So we can get its inverse. We need the determinant to figure the inverse. So the determinant is going to be 5 times 1 minus 2 times 2, which is equal to 1. So the determinant is 1. That means we can go ahead and move forward. It's not 0. If it was 0, we'd have to stop and say this is impossible. Excuse me. So to get our inverse of A, we know that it's 1 over the determinant, which is 1. And then we take this order. Let me blow this up. 5, 2, 2, 1. So this is my A, B, C, D. So to do the determinant, to do the inverse, we know it's going to be I just start at the bottom and work up and do like that. So it goes A, B, C, D, and then negate the two middle. The diagonal on the forward slash, you negate or flip the signs on. So A is 5, B is 2, C is 2, and D is 1. So A, B, C, D. Now flip the signs on the forward slash diagonal. So now we have 1 over 1 times 1 minus 2, negative 2, 5. So when you multiply that by 1, you just get that matrix, 1, negative 2, and 5. So now we've got the inverse matrix, right? So now to finish this problem, we have to multiply B times the matrix, right? Times the inverse, So we're going to multiply each side by the inverse. Now, they're just showing it one step at a time, and I don't like that. I don't even show this step, right? But they are showing you when I multiply my A matrix times its inverse, I get the identity matrix, which is like multiplying a matrix by 1, right? We talked about that in the last couple of lessons. So there it is showing when I multiply these, I get the identity matrix. So now that goes away, and we're left with X is equal to our inverse of A times B. So now everyone calculate that and tell me what your answer is going to be. You can do it on the calculator or by hand. Because it's a 2 by 2, it's pretty easy by hand. Remember, you're just multiplying across, down, across, down, across, down, across, down. Okay, go ahead and use it a little bit longer. If it goes out or turns really, really light where you can't see it, then I'll change them out. When you finish this, go ahead and start on the next problem, number 2, which is even easier. And on our test, you're going to have they're both going to be 2 by 2 matrices. I'm going to go ahead and give you the answer to number 2 so you know if you're getting it right or not. Okay, and then the answer to 1 is 1, 4, 3, and 2. Right, so I'm going to give you about 5 minutes, and I'm going to pause the video to finish this up. I'm going to pause the video now. $20, $10, Okay, so everybody, if you're not finished, pencil in your answers and work these over the weekend. Make sure you know how to work these before the test. Are there any questions before we move forward? Okay, remember you're going to get to use these assignments, your assignment sheets, your workbook pages that you've written on. And if you've solved them on a separate sheet of paper, you can bring that stapled together, but you will turn in all 4 assignments with the test on Monday. So you'll take the test Monday, open assignment. Any questions on that? Okay. Now, I wanted to point out what's on the test. For chapter 12, you have problems 1, 2, and there's 2 problems for problem 3 and a problem 4. So there's 1, 2, 3, 4, 5 problems off the first 12-1. On 12-2, there's a problem 1, a problem 2, a problem 3, and 2 problem 5. So 2 different types of 5 on 12-2. And then there's on 12-3, you've got problems 1, 2, and 4. And then for 12-4, which is what we're doing today, just the problem we solved is on the test Monday. What we're getting ready to do, you still need to know so you can move forward to pre-calc and calculus. So we're going to do one more problem set and then we're done. This is how to look at a systems of equations and turn it into matrix operations and solve it through matrices. So this is about looking at an equation and turning it into the matrix, right? And from there you know how to solve, because we just did it, and how to solve that equation. So if they give us, I hate to do this, I'm not going to use the shade today, so because it crashes my program. If you take 2 equations with an x and a y, how do you turn this into matrices? Okay, so what you want to do is take all your coefficients. You're going to have a coefficient matrix, a variable matrix, and a constant matrix. We're going to call the coefficient matrix our matrix A, our variable matrix X, and our constant matrix B. So in our coefficient matrix from these equations, we're going to extract the coefficients. So we've got for 4, -5, 7, and 3. There they are. 4, -5, 7, 3. So what kind of variables are we looking at? An x and a y. Right? So there's our x and our y, our variable matrix, and equal to our constant matrix, 6 and 1. See how they turn that into matrices? So we've talked about that ax equal b. So we can do the same thing here. This is a times x equal b. And here it is right there. Does everybody see that? Okay, let's look at our homework number 3, and then we'll go back to do one more. So on number 3, we've got variables x and y, and we have coefficients, and we can turn this into a matrix operation. So we need matrix A, our coefficients. So what do we have? A 3, a 2, that's a 1, and a -4. And we know our variable matrix, we've got x and y's, so just x, y. And that's equal to our constant matrix, 9, -8. So there's the first, well, problem number 3 written as a matrix equation. So this is the coefficient matrix, because it says to identify coefficient, the variable, this is our variable matrix, and the constant matrix. All right? Any questions? All right, now work number 4. Okay, and you should be done or close to done. That's an A, not a 9. So you should have matrix, your coefficient matrix, don't forget to label them, variable matrix, and constant matrix. So you've got 1, 4, 3, 2, coefficient, variable is AB, and constant is 13, 19. Are there any questions? Pretty easy. I'm not going to make you solve all these because you've already learned it, but this is what you start calculus and pre-calc with. All right, now let's go back and look at one other type. Our problem B here. So this one, nothing's really lined up. It doesn't pan out very well. You have some A, B, and C in the first row, a B and a C in the next. There's not an A. And then third row, you've got 5A equals 3C plus 1. So you've got a C on the other side of the equal sign. So what you have to do is just line up all your equations. We have 3 of them here, so it's going to be a 3-row matrix. So first thing you want to do is get everything in order in columns, A's, B's, and C's. So here, you're going to have to shift this A over here to 5A, and then you're going to have to subtract 3C from each side. So right here, you're going to have a -3C. So you have 3A and 5A in the first column, 5B and 7B in the second column, and then -12C, 2C, and -3C in the third column. And it looks like this when you get them all lined up and put in the right place. Everybody see that? Now, wherever you're missing one, that's just a 0. So now create your matrix. So let's do our constant matrix, or excuse me, our coefficient matrix, 3, 0, 5, and then 5, 7, 0, and then -12, 2, -3. And we have 3 variables, A, B, and C. And then we have our constants, 6, 8, and 1. All right, so now we can put all that together. The matrix equation becomes matrix A times the variable or coefficient matrix times the variable matrix equals the constant matrix. Are there any questions on that one? So with all of that now, you've got everything. That's the last thing I'm going to teach you this year. So I want you to work through number 8. So through the first side of this assignment, and then you're done. Okay? Any questions? All right, I'm going to put your answers up here so you know you're getting the right thing, but towards the end of the class. And that concludes our lesson. So thank you. I'm going to give you your answers real quick. All right, so for number 5, it was 5326 for your coefficient, x and y for your variable, and 3538 for your constant. Then for 6, you've got 310, 1, -14, 0, 32. Next matrix, variable matrix, XYZ. Constant matrix, 9, -5, 7. Number 7, you're going to have 4, 2, 1, 3. Variable, that's your coefficient matrix. Variable matrix, XY, equals your constant matrix, 2, -12. And then lastly, you're going to have coefficient 2, 1, -2, 4, 0, -1, and 0, 5, 3 as your coefficient matrix over A, B, C equals -6, 10, and 8. So coefficient, variable, and constant. Okay? Please keep your seats till the bell rings. And this concludes our lesson and our textbook and our course. So study well and see you Monday. Thank you.